Yes, and we're live. Okay, I'm going to be reminding you of this many times in the next several months, because obviously we're at the beginning of February. We have to go through February, we have to go through March, we have to go through April. And then May is going to be weird, because May is when you're taking your AP test. And an email was just sent out yesterday by College Board. I don't know whether or not you guys are aware of that email that was sent out, but they came up with a possible system for you guys taking your AP test in May. Obviously, last year, everything got thrown to crap, and everybody had to take the AP test online, and it was severely shortened. So what they have now, and I'm going to kind of go through this information just not in great detail, but basically there are 3 administration time windows in which people can take the AP test. The first one being in school, second one being in school at home, the third one being in school at home. Personally, I think that it would be best to kind of just get it done with the first administration of the test, but I do understand that there are some people who would feel way more comfortable taking this thing at home. Keep in mind that whatever they give for administration 1, it is absolutely not going to be the same test that they give for administration 2. You better believe that, because even though they have you sign these confidentiality agreements, you better believe that people break them. So just number 1 thing to keep in mind. Scroll down a little bit here. Here we go. Here are some of the highlights, and then I'll talk about the exact date that they're offering AP Stat. So they're offering 3 testing dates for each subject in early May and mid-June. Paper or digital exams are offered depending on the subject and the exam date. That doesn't apply to you guys. School can use any of the testing options as needs and circumstances warrant and are free to use multiple options given during a given exam administration window. Schools make all decisions about which exams are offered. Now, we just got this email yesterday. So what's Barnegat going to offer? I have no idea. We'll see what happens. Students won't be able to choose exam dates on their own. Beginning in early March, AP coordinators will be able to assign students to administration 2 and or 3 exams if needed. Do you guys know who the AP coordinator here is? You guys know Ms. Gerke? Yeah, that's who it is. Just giving the heads up. We extended the deadline for final digital. Oh, that doesn't apply to you either. So just little things to keep in mind. They're trying to figure it out the best they can. Here we go. The first date available for statistics would be Monday, May 17th. Monday, May 17th, which again, usually statistics is on the later end of the AP schedule. Yeah. Oh, exam, whatever that is, I don't know. But yeah, Monday, May 17th. So that basically gives us March, April, May. That gives us a little more than 3 months to get ready for this thing. That's more than enough time. Obviously, keeping in mind that in the beginning of April, you do have a bit of spring break. But again, that shouldn't affect us too much. It's a weird system. Again, they're literally flying by the seat of their pants. Did anybody take an AP test in a different subject last year? Yeah. What subjects? Biology and chem?
I was going to say my brother,
Yeah.
He took his AP Calc last year.
Yeah.
The exam was so short, and it was 2 questions, and they were both
Yep.
like kind of open-ended with parts. It was the weirdest thing. He said it was so weird and nothing like he's ever done before. So.
Well, last year was such a, I'm just going to call it a crap show. Last year was such a crap show. I had a student who I was like convinced that student's going to get a 4 or 5 on the stat test. Convinced that student's going to get a 4 or 5 on the stat test. They didn't, because something messed up with the submission of the test, where they had submitted it on time, something messed up with the computer. Then they went through the secondary protocol where they took a picture and they emailed it to the proper thing. But then College Board still didn't accept it, never got credit. Like, you've got to be kidding me. This kid was like a guaranteed 4 or 5. But that's College Board. That's the crap show that they run. And apparently this is the crap show they'll run this year. So, yay! I'm going to be in communication with Ms. Gerke, as I'm sure all the other AP teachers will be as well, to make sure we understand exactly what option Barnegat High School is going for. I just wanted you guys to all be on the same page, simply because it's being worked out. May not be perfect, but it is being worked out. So this would absolutely be the earliest if Barnegat decides to go with that option. Well, Ms. Gerke, if they do in school, what about those kids who are online? I don't know yet, because they haven't told me what they're going to do yet. So we'll see. We shall see. Okay. For those of you in the chat, I can see you right there. They got about 80 of you right there. If you could leave a comment for me in that little chat section, that'd be fantastic. Oh, good morning, Mr. Markey. How wonderful, Mr. Markey. Anyway, what I'm going to ask all of you, if you do not already have them out, no. I need those Chromebooks out and open. Aha, I fooled you. Don't shake your head at me. The one day what? I'm sorry. Now, I would suggest, because we are going to knock out a quick quizzes real quick. I would suggest if you want to use them, you can use your notebooks, because this is just a practice. This is just going to be a practice. Let me get the code up here so that people can get logged on. Let's see. Chapow. Chapow. There's my code. I'll type that code into the chat. It's a 924 380. Chapoom. 924 380. There we go. 924 380. There we go. Now, these questions are all going to be about Chapter 17, sampling, distribution, models. At some point, you may need that calculator on the Chromebook. Just be ready for it. There are going to be some questions that legitimately take you 10 seconds. There are going to be some questions that may take you a few minutes. We'll see how this goes. There's 20 questions. Now, as you're logging in, let me just give everyone in the chat and everyone here just a heads up about one of the questions. I didn't create this particular quizzes, but I was going through the questions, and there was one question in regards to an appropriate sample size. And as I've talked about, depending on the textbook that you are learning from, the minimum sample size that they would find acceptable changes slightly, depending on whose opinion it is that you're talking to. Some people would say, well, since you have to have a minimum of 10 successes and 10 failures in regards to proportions, that you should have a minimum of 20. Well, more than 10 really should be like 21 or 22 or higher than that. And some people are like, well, no, just make it 30 and be done with it. So there is a question about sample size in here. I'm just going to give you the heads up on that. Two of the options are 20 and 30. And it's like, well, which one is it? Well, I'll just tell you, for this particular quizzes, it is 30, just so you don't get messed up. I don't want you to ruin your quizzes streak if you have one going. But yeah, for those of you in the chat, make sure that you are logging in. I see you all there saying hello. Oh, a couple of you said hello. Anyway, what do we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There should be, oh, I got 13 here, but there should be way more than 13. I'll give you guys another moment to kind of get logged in, because I know some computers were getting started. Did you take AP Stat?
I didn't take AP Stat. I took an intro course in college, and then I took probability and mathematics and statistics.
Nice.
They were like my two option courses.
Yeah.
I was really like into probability and stats and stuff like that. So I should know most of it, but it might need a little recovery.
Are you joining in?
I'm gonna try to. I don't know if I can sign in. I'm trying to do that right now.
I gotcha. Now, mind you, even if I can't even talk. even if the quizzes get started, you can still join mid quizzes.
Okay.
So,
Do you think I should click teacher or student, or doesn't matter?
what email is it? Your college email?
I actually used the email from my placement last semester because that one already had it in the account.
Then go for it. Yeah, make it a teacher. Okay, I want to get this thing started. I know not everyone is logged in just yet, but again, if you haven't logged in, you can join mid quizzes. That code will be on the board in white. I've already typed that code into the chat, 924-380. I'm going to get this thing started so we can get moving. Clip-how. teach you.
Yeah, I know. There was a couple. Every question I got wrong, I was like, oh, I should have known that.
They have an optional quizzes or reflection questions. You know about that?
I don't. I saw something that happened in the review one.
Well, yeah, I turned off redemption questions. That's what I'm saying. Like I said, as a teacher, you can turn on redemption questions where if they get a certain streak, then they can utilize that streak in order to access a redemption question. You know, in order to get it right again for a second. You know. But I found that it's just practice. So. I'm going to give you guys another 2-ish minutes to kind of wrap this up so we can begin reviewing problems. All right, I'm gonna click the end button. So I want to see what we can do with this. Click, click. There we go. Now, there are going to be certain questions that I would like to review with you. So what I'm going to ask you to do is this. Chromebooks, close them. Obviously, except for you online. You online right here, stay open. But the rest of y'all can close those Chromebooks, and I need those notebooks. Now I need them officially out and open, because I would like to review some problems with you. There are certain problems that I definitely think are more problematic than others. Well, let's see what we can do with this. Boom. Come on. There we go. Ooh. And this. All right. For those of you in the chat. Obviously, I'm going to have the chat open in case you have any specific questions. So please feel free to do so once I get the thing loaded up here. For everyone else, I'm not obviously going to hit every single question on this thing, but I want to hit some of the more important questions. Let's start with these three right here. Now, these three I'm not actually going to write down, but I would like to talk a little bit about them and why the answers are what they are. Notation in AP Stat is incredibly tedious. Let me repeat that. Notation in AP Stat is incredibly tedious, but they do expect you to understand what each symbol typically means. Now, I turned off the show answer thing for this just because I want to cycle through these three questions that are about to pop up. One of them is this X bar and standard deviation of X. The next is this mu of X bar and sigma of X bar. And the last, of course, is just mu and sigma. Now, as we've talked about from the beginning of the school year, this notation, mu and sigma, is in reference to population parameters. When you're using those Greek letters, you got to recognize the population parameter notation, which is why, what does it represent in this context? It has to represent the population. Now, I understand why a lot of people would potentially pick the sampling distribution, possibly because of the order in which these questions popped up. I think they came in random order at you guys. I think I shuffled them. Yeah, I think I shuffled them. When you go to these symbols right here, X bar, and the S technically, is in reference to the sample statistic, which a lot more people did pick sample statistic more so than the other two choices. We do have to recognize that. But the notation right here, which the vast majority of you did pick correctly, is the sampling distribution notation. The way that I wrote it into our notes the other day was like this. But this is just another way of looking at it. It's the sampling distribution notation. We have to be very careful with that kind of thing because they will eventually get you very hard on the AP test if you're not using the proper notation for things. More specifically, mu and sigma in regards to standard deviation or mean and standard deviation. Please be careful with that. Question. Obviously you wouldn't know from each other because it was kind of shuffled. This one, I don't know if it came up first or not, but it seems like the vast majority of you guys got that. But then when I flip over here, show those answers. Well, not that one exactly. This one right here. Not a lot of people got this one. Actually, it's not really a question, more along the lines of an observation. I'm not sure what order you guys typically got these questions in. But I can see where if you got this question first and you glanced at the notes that I gave you the other day, you'd be like, oh, very quickly, boom, sampling distribution. There's a big difference between the population, the actual sample, and the sampling distribution. Remember, the sampling distribution is in regards to means. It is in regards to taking an average. I go out and I take a sample of 50 and I have an average. You go out and you take a sample of 50 and you get an average. Everyone goes out and takes a sample of 50 and you get an average. We put all those averages into a distribution. That's what this thing is in reference to. Those questions. Let's actually write something down though. Click. And click. Do I want to do that one first? I want to do a question. Nah, not that question. I know which question I want to do. Let's just start with this one. I'm going to write something down. I'm going to have you guys write it down as well, but I'm not going to write down every piece of information. I'll switch the camera over in a moment. But a Gallup poll of 1,785 adults. P hat is the proportion that went to church last week. Now, this is a multi-step question, which I'm going to add a bunch of information to it as well. So, there we go. First, begin by writing this stuff down. A Gallup poll of 1,785 adults, 40% went to church last week. There we go. Now, just a couple of observations about these numbers that are popping out at me. First of all, 1,785 adults is the sample size. I would immediately believe that that sample size is large enough, but there are a few things that we can kind of take into account. I believe it was U.S. adults or just adults, just a random sample of adults. Oh, there it is, 40% of all U.S. It says it later on, right? Yes. There are approximately, 350 million people living in America right now? I don't exactly know how many adults there are. Yeah. But regardless, one can then assume that the number 1,785 is less than 10% of the U.S. adult population. This is one of those conditions and assumptions that we have to talk about in regards to using a normal sampling distribution. 1,785 is definitely less than 10% of all U.S. adults. Fair assumption. Sample size is large enough. Cool. Notice the use of P hat. P hat is in regards to the sample. P hat is in regards to the sample. Yeah. A newspaper report claims, there it is, I was trying to find the right wording, claims that 40% of all U.S. adults went to church last week. Suppose that the claim is true. What is the mean of the sampling distribution of P hat? In fact, I'm going to have to alter that notation just a tiny bit on my piece of paper, which I won't have to cross anything out or anything along those lines. I'm going to alter this like that. In stat, the details that they give you make all the difference in the world. By me putting that mu of P hat in, or that mu in front of the P hat and making it that function notation, I'm simply stating that this is the assumed mean. This is the assumed average proportion that we would then go ahead and move forward with this problem. P hat is in reference to the sample. The only time I would do P hat equals a number is if that sample was taken. But look at the wording of this question. The wording of this question is absolutely icky, for the lack of a better term. The Gallup poll asked a random sample of 1,785 adults whether they attended church during the past week. Let P hat be the proportion of people in the sample who attended church. Then the newspaper report claims that 40% of all U.S. adults went to church last week. Suppose this claim is true. This is kind of weird, because at first they start talking about a Gallup poll of a random sample, and then they say that the newspaper report claims. They don't actually make the connection between the Gallup poll and the newspaper article. I like to criticize how problems are worded. It's very weird. Who would you guys pick for this? Okay. Question. What made people pick these other numbers? What made people, most people picked the correct answer, obviously, but some people picked 0.4 44.56.60. Well, why? I don't know. There must be a reason why people are picking these numbers. Maybe they think it was a trick question. Let me see what the next one says. Gallup poll, blah, blah, blah. Calculate the standard deviation. Okay, so same information that we got going on here. We're going to need that formula, but we're going to need the formula for standard deviation. What's nice about the formula for standard deviation is that they typically give it to you. There we go. They typically give you that piece of information on the formula sheet. P times Q over N square root. Actually, they don't give it to you as Q. Let me show you. 2019 AP Stat. Response questions. Where is it? There it is. Just so you know, on the AP test, they give it to you looking like that. Just so you're all aware. It's the same information. They just want you to recognize. I don't know. Why can't they just put Q there? But they just want to do 1 minus P for some reason. Flipping back. Actually, I want to go here. 0.4 times 0.6. I already forgot the number. What was the sample size? Square root of that answer. Of course, you could type this whole thing in at once if you wanted to. Approximately 0.012. I want to go here. Oh, well, they went detailed. What did they do here? Hold on, what did I get? I got to go farther. I can't go 0.012. I got to go a little farther now. 0.0116. There we go. I didn't look at the choices that they gave me. They went a little bit farther with that one. Please be very careful with how you're typing these things in. Because if you round too early, if you round the problem too early, like I just did, it can really mess you up. There we go. I know, typically I usually go 3 decimals. But being that it was a multiple choice question, yeah, they really wanted to get you to think about that one. To the next one. They changed it over. Okay, I'm going to go back to this question a little bit. I'm going to actually add my own question. There we go. What is, and I want you guys to write down this question as well. What is the probability of getting a sample proportion of give me a percentage that's more than 50%, but that's like somewhat reasonable. Like don't go like 99 or some junk like that. 70. Let's go with 70. Sure. Sample proportion of 0.7 or higher. Question mark. So we're going with that sample size, 1785. We're going with 70% or higher. I want to start talking about assumptions and conditions with you guys. Now, I verbally kind of mentioned them, but in order to use a normal distribution, you're going to have to hit those assumptions and conditions. Please remind me, name one of the assumptions and conditions that we dealt with in previous class periods. What has to be true in order for us to be allowed to use a normal CDF to solve this problem? Carefully thumbing through our notes. I've mentioned a few of them, but I do want to write them out for this problem. What do you got? Yes, we need that. Now, here's the thing. Sample size is 1785. It seems very obvious that we're going to get more than 10 for each. Yes. But we still have to write it out and check it. So, let me get another piece of paper here. Assumptions, conditions. When it comes to stat, you need to get in the habit of writing out your assumptions and conditions in the context of the problem. So he says more than 10 expected successes, more than 10 expected failures. Now, question. I have two possible proportions to deal with here, 0.4 and 0.7. Which one do I use to calculate the expected successes or failures? Which one? I couldn't hear you. 0.4? Yeah, it is 0.4. And the reason why it's 0.4 is because of the very, very important word that he just said earlier, expected. The expected successes and failures. See, the thing is, like, we're just, what are the chances we get 0.7 or higher? Well, that's not the expected. We are expecting 40%. So we have to do that calculation with 40%. So I'm going to do 0.4 times 1785. I'm going to do 0.6 times 1785. And it may seem silly to actually have to write this out, but I need you guys to get into the habit of doing this. N indicating that it's greater than 10 expected successes and 10 expected failures. We would expect 714 out of that sample to be going to church. We would expect 1,071 in that sample to not be going. What else? I need to knock out all of my assumptions and conditions. What else do I need to talk about? Because here's the thing. I have a lot of people who can do the calculations for the normal CDF. I have a lot of people who can spout off a lot of information about the problem and what is true and not true. But if you can't get the assumptions and conditions, then you will never get full credit on these open-ended problems. Everyone's afraid to say the wrong thing. Good. Repeat it one more time. There was noise back here. Be more specific. What do you mean? Because now I know what you're saying. I want to be very clear. I know what you're saying, but I want you to clarify yourself for the sake of what I'm about to write down. Go ahead. Repeat what you said before. Now, hold on one second. You said the words you're using, the sample population, those don't typically go together. Let me write this down, and let me juxtapose what I'm about to write against what you just said, okay? 1785, let's just say U.S. adults, is less than 10% of U.S. adult population. I want to be very clear with how that's being worded. Because you kept saying like sample population. But the comparison that's being made is that the sample size is less than 10% of the population in the problem. That's what it's referring to. This had to be true in order for us to use that binomial model in the previous chapters. This has to be true in order for us to assume something. It's all of these assumptions kind of build up to something. What is one key assumption that we had to make with the binomial model that we also have to make with this? What's one key assumption that you typically make on the 4th of July? Nobody gets what I'm putting down. What do you celebrate on the 4th of July? Independence! I was going to say, none of y'all are Americans. I know, right? Independence. The reason why independence is so important is because we need that 40% to remain consistent. If we had a sample size that was more than 10% of the population, we kept plucking people out of the population and sampling, did you go to church, did you not go to church, that kind of thing. We need that 40% to remain consistent. But if we had a sample size that was more than 10% of the population, then that 40% may end up changing. This is one of the key things that we need to hit upon. Here, let me move a little forward because I am running a little short of time here. We can say that 1785 adults is a large enough sample. Remember that concept of being a large enough sample. Large enough. Is it large enough? I guess so. It's a very fluffy statement, as we've said in the past. Now, the reason why I grabbed my little notebook here, I wanted to get to what I had written down in a previous class period. Oh, I didn't organize it. Silly me. Nope, I only wrote the binomial model down there. Where did I put those other ones? Oh, there they are. I never organized them into the notebook. Or did I? Nope, I didn't. Crap. I don't know where they went. I'll have to find them another time. But they were the assumptions and conditions that we wrote down. I was just trying to clarify what I had in my notes, unless I left them on my desk. Were those the notes that I gave you when I was at home? When it was like I wrote like assumptions and conditions and I wrote them all in great detail. Yeah, I was sitting at my desk. They're literally probably still sitting there. Blast. Oh, well, that's okay. Independence. Independence is not just a word that you can write and be done with how it's stated. You have to put it into the context of the problem. You have to put it into the context of the problem. Totally misspelled independence. Let's try that again. What kind of a real American am I? Independence is assumed amongst U.S. adults' church attendance. It's a weird way of wording that, but here's what it comes down to. You cannot just say independence and be done. You have to put it into the context of the problem. Which, by the way, there is one more statement that we need to make in order to ensure that independence. Independence is ensured by the fact that we do have less than 10% of the population in the sample. But independence can be assumed as well based on one more key factor. What type of sample was it? What type of sample was it? The problem never actually stated this, but how was it collected? Ooh. I could say starts with an R, ends with an andum. Yeah, you got it. How'd that happen? I don't know. But there has to be a random selection. Has to be a random selection. sample is randomly selected. Wait a minute, Mr. Markey, I have a question. Let's go back to the problem itself. Oh, it does say it. It says it right there. I apologize. I thought when I first read it, I may have skipped over the word. I thought it just said a Gallup poll asked a sample of 1785 adults. What I was going to say was it's a Gallup poll, and because it's a Gallup poll, Gallup is a reputable polling company, then it's fair to assume that it was a random sample. But you got me. It does say random. So the job is even easier. So I can even say sample is randomly selected, stated in problem. That's even easier. Look at all this junk right here. I want you to take in this moment. Because what's going to end up happening in the future of statistics is this. You are going to be faced with a problem. And you are going to have this desire, okay, I can solve this problem using a normal CDF or using this function in the calculator. Yay! But before you even begin that process, you need to go through all of these assumptions and conditions to ensure that you are allowed to step forward. This is huge. This is huge. Now, if one of these assumptions and conditions is violated, it depends on how grievously it was violated to determine whether or not you can move forward or not. For example, let's just say, for example, that this number, I don't know, somehow you found out it was like 10.1% of the population. 10.1. Oh no, it violates that 10% condition. Well, technically, you would be allowed to move forward because it was so close, but you would have to make those kind of statements and conciliations in your conclusion. Oh no, I had 9.5 expected failures. Okay, you didn't hit it. But again, you technically would be able to move forward because it was so close. You just have to make reference to it and say it in the conclusion. Hey, we didn't hit this condition. It's similar to the idea of extrapolation. Is extrapolation trustworthy? No, probably not. Extrapolation is not probably trustworthy. But do people still do it? Yes. Yes, they do. Why? Well, people want to know what's going to happen in the future. But it is extrapolation, and we take that result with a grain of salt. If you don't hit one of these assumptions and conditions, but it was like kind of close, technically you would be allowed to move forward, but you would have to take your conclusion with a grain of salt. If your sample size was 50% of the population, sorry, you cannot move forward. If your sample size is like 5, I'm sorry, we're going to have to take another path. If your expected successes is 1, sorry, can't do it. Only if it's borderline are we allowed to take a step forward. Based on all of this, we are allowed to go ahead and attempt to answer this particular question based on normal CDF. Normal CDF, 0.7, big number, 0.4, 0.0116. It seems tedious to have to write out all of those assumptions and conditions, but I need you to get in that habit, especially when it comes to samples. Sampling distribution is just the first step into a larger world. It's going to be amazing. I'm excited. Let's figure out what this junk is. Here we go. Normal CDF. 0.7, big number, 0.4. I'll just put 0.0116. Oh my goodness gracious. Look what we got there. I wonder. Let me try this one again, but let me actually type in the full standard deviation because I'm going to tell you exactly what you can write. Let me do square root 0.4 times 0.6 divided 6 divided by 1785. Oh my goodness. Question. Is the answer actually 0? You're shaking your head no. Why? Why? Anybody? Go ahead. Exactly. The calculator, the number is so stinking small, the calculator doesn't know how to express it. So I'm going to say approximately 0. I'm going to put approximately 0. But yeah, the number is so stinking small. It's essentially 0. It's the equivalent of a coin landing on its side after you flip it. You guys know the number infinity, correct? Do you know the number infinitesimal? No? Infinity is not a number. It's a concept that you're trying to get to, but you never actually reach. Calculus tries to bridge that gap, blah, 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 blah. Anyway, infinitesimal, think of the smallest possible positive number. Think of the smallest possible positive number. You can't do that. Infinity is not a number. It's a concept. So you can't actually do that calculation. You can do limits, but that's calculus. Huh?
Range is basically like also can keep adding zeros to the power of one, like you put 0 point and then keep adding zeros after that.
Exactly. Yeah, say again? Yeah, it is. It's impossible. There is no smallest positive number because of what you just said. Because you could just basically throw in another 0 in a placeholder and expand it even farther. Or divide it by 2 again. Anyway, I am going to be assigning you guys some problems out of the textbook. I will be posting that on Google Classroom before I leave the building here today. Please be aware of that. And we'll see where we go. Next week, what do I have you? Tuesday, Thursday? Yeah, we'll see it there. Anyway, there's the bell. I'm going to sign off. If you haven't already left a comment in the chat, please do so. I'm going to sign off in a moment. Thank you too. See you guys.